Obviously it will be tough, no? Okay. ఇది ఎలా అంటే 10 meters రోజు పరిగెత్తి ఒకేసారి 100 meter రేస్ లో పార్టిసిపేట్ చేసి పరిగెత్తి కదా 100 meter రేస్ యూ కెనాట్ రన్ యూ రన్ ఫర్ 10 meters only. The same thing is happening. Okay. Nobody completed. There is 5 members completed out of 30. Around 30. Srjc, good morning. And from tomorrow onwards, no, if you don't be in the class by 8 o'clock, I don't allow. So I log in at 8, around 8:01. Usually log in at 8 or 8:01. Okay. By the time I log in now, you should be in the class. Otherwise, I'll ask them to stop to join into the class. Okay, from tomorrow onwards. Remember that. Just slowly join. Okay. So no doubt in Bipc. Almost 6 minutes, but nobody asked about it. So I think all questions of Bipc got. Has nobody asking any doubt in Bipc? Pritham, you have completed Bipc? Pritham. Okay. Yeah. So we discussed momentum questions yesterday. Okay. Change in linear momentum when unbalanced force is there, when net force is not equal to 0. So in the entire Newton's law of motion, you will have two cases. One is net force is 0, other one is net force is not equal to 0. Okay. So these are the two cases we are having. Net force is 0 means we say that object is in equilibrium. Then you know what to do. You can take the components of all forces and opposite forces should cancel out. Means they should be equal. Opposite forces should be equal. Then automatically they will cancel out. Okay. When three forces are there, resultant is 0. Then you can apply the Lam's theorem. So those are the two methods to solve the questions of equilibrium. Now, if net force is not equal to 0, okay, we are applying the force on the body. That force value is not equal to 0. Okay. If net force is not equal to 0, then you will get two cases. One case is what? Force acting for very small time interval. The second case is what? Force acting for long time interval. When force is acting for small interval of time, then we say that the force is called as impulsive force. So hope all of you revised. Okay. When forces are acting for small interval of time, force is called as impulsive force. And these impulsive forces does not accelerate the body because they act for very small interval of time. So what they do, they change the velocity of the body. So that only we are calling it as they change the momentum of the body. So hope all of you realize this. Okay. So F bar is equal to, again we are using the Newton's law. F bar is equal to dp bar by dt. Okay. So F bar into dt is equal to dp bar, which is final momentum minus initial momentum. Then F into dt we call it as what? Impulse. F into dt we call it as what? Impulse, which is P final minus P initial. Final momentum minus initial momentum. Then impulse is equal to, we can write down integral F bar dot dt also. Why? Because the force is acting for small interval of time, but you cannot say whether it is constant or variable. The constant or variable is applied. Okay, no? Then impulse is equal to integral F bar dot dt, which is equal to P final minus P initial. So which I write down what? I can write down as it is integral area under the graph of force and time. We can say that change in momentum. Okay, so these are related to integration part, basic mathematics. Hmm? Okay. When force is acting for long time interval, then it will accelerate. So acceleration is equal to force by mass. F bar by m. So even we solved some examples for impulse also, how the impulse is acting on the body. So impulse will act usually when body is hitting the some surface. So I've given all the three examples I've given. So we solve some more examples also. So hope all of you revise these three examples. If you're not revising, then you are under danger zone, no doubt. Okay. Yeah. So now we see that accelerating body cases. Accelerating body. So when acceleration of body, acceleration of the body will be there when force acts for long interval of time. Okay, so I'm going with the very fundamental examples. Example one, on the ground, obviously smooth. In the entire Newton's motion, we'll take the smooth surface where there is no friction. Okay, but it's not rough surface. What is the rough surface? What is the friction? How it will act? What are the types of friction? That all we see in the next chapter. Okay. Okay. Now I'm keeping one object of mass in. Object of mass in. Now I'm applying the force F. Only one force I'm applying. Only one force I'm applying towards right. Towards right, I'm applying the force F. Then what happens? How the object will move? Object will move towards right or left? Only one force I'm applying towards right. So object move in rightward direction or leftward direction? Obviously rightward. This is very simple. కాబట్టి ఇదే కేసుని మీరు ఫోర్త్ స్టాండర్డ్ థర్డ్ స్టాండర్డ్ స్టూడెంట్స్ కి అడగండి. You ask to third or fourth standard student. Before don't tell them like force and acceleration. Ask them there is an object we are pulling in rightward direction. In what way the block will move? They say that rightward. Okay, so that is a very common thing. So in rightward direction it will accelerate because force is acting in rightward direction. Then what is the acceleration of the body is equal to force by mass. F by M. I mean simplest case of the physics. ఇంతకన్నా ఫండమెంటల్ ఏ ఉండదు ఇందులో. ఓకేనా? Next example 2. See, I'm slowly increasing the toughness. Okay. Just a minute. So hope everybody able to see this. Okay, suppose I'm taking one body of mass, there is a 10 kg, and force is acting 30 Newton forward and 10 Newton backward. Then what is the acceleration? What is the direction of motion of the body? What is the acceleration? What is the direction of motion of the body? Just a minute, I logged off in second account. Start account. Okay. So I think you are able to. Okay, in what direction object will accelerate? So now opposite forces are acting, but they are not equal. So they don't cancel out. So this is called as unbalanced condition. If they are equal, we call it as balanced condition. Okay. 10-10 unconditional, then balanced condition, object will be at rest. Initial velocity, object can be at rest or can be moving with uniform velocity. Now 30 is acting, more force is acting towards right. Then it will accelerate towards right. Then what the acceleration is equal to? Net force acting by mass. What is the net force value? Two vectors are there. Okay, now both are opposite to each other. Then what is the resultant of two vectors? Resultant of two vectors will be A minus B. I think you remember this. Then acceleration value is 2 meters per second square. In what direction? In higher value of the force towards right. Sir, post Rashega Dharmara.
Sir, good morning, sir.
Good morning, sir. Sir, the chart account on the chart account, then post.
Okay, sir.
Yeah.
Okay, sir.
Yes. Thank you, sir. Now you can send your answers to chat account, okay? So I think all of you got this acceleration. See, I'm going with a very fundamental way. Okay. Now let us go to the example. For example, suppose on the ground there is a block of mass m. Now force is acting at an angle theta. Force is acting at an angle theta with the horizontal. Now force is not horizontal. Force is at some angle theta. Okay. And the object is traveling on the ground. Object is not lifted off. And the object pike move out later. Object is moving on the ground. If object moves on the ground, find acceleration and normal reaction on the block. Find acceleration and normal reaction on the block. See, already I told that block is moving on the ground. So I have given some logic. Block moves on the ground. This is smooth, obviously. So no need to tell. Till friction, all the surfaces are smooth. Okay. So block moves on the ground. So I'm saying that block is moving. Block is moving on the ground. So then, what is the acceleration of the block and what is the normal reaction on the block by the ground? How much normal force is acting on the block by the ground? I told you, no, we are always interested in the forces acting on the blocks, not on the ground. Okay. So when forces are at an angle, then how to solve them? Forces are at an angle. You can solve them. Block of mass m Now F is the force at an angle theta. Then what you have to do is you have to make into components. F cos theta in upward direction, what is the force acting? F sin theta. Now tell me, very good, Chandra. Perfect. Now tell me which component will accelerate the block? Which component will accelerate the block? Which force will accelerate the block? Or which force will move the block? Very good. Maria. Very good. Yes. Everybody is answering same. Very good. Then what is the acceleration of the block I can write down? So this is called as accelerating force. This force we call it as what? Accelerating force. Okay. F cos theta we call it as accelerating force, which will make the body to move or which will make the body to accelerate. Then what is the acceleration of the block I can write down? So there is only one force which is accelerating the block. F cos theta. No other force is acting. Because F side is acting upward, mg will act downward. The normal reaction on the block will act upward, away from the surface, perpendicular to the surface and away from it. So on the block, normal reaction will act upward. I think all of you are able to draw this free body diagram. Then F cos theta, normal reaction mg will cancel out. Why? Because vertically it does not move. All vertical forces will cancel out. So because block is moving on the ground, I've given that block is moving on the ground. That means all vertical forces will cancel out. So this is called block is in vertical equilibrium. Block in equilibrium means all force will cancel out. But here only vertically forces are cancelling out. Here only forces are cancelling out vertically. That's why we call it as what? Vertical equilibrium. So vertically they'll cancel out. And which force will move the block? F cos theta. So acceleration we can write down as what? F cos theta by m. Then how to find out the normal reaction? By vertical equilibrium. Means vertically forces are cancelling out. Okay, vertical equilibrium, what I can write down? Total upward force should be equal to total downward force. Net force is 0 vertically. Vertically net force is 0. Okay, so total upward force n plus F sin theta should be equal to what I can write down? Mg. Total upward force is equal to total downward force. Then what is the n value I can write down? I can write down that Mg minus F sin theta. Mg minus F sin theta will be the normal force acting on the block by the ground. If you want to write out normal force acting on the block by the ground. Okay. So let me know anyone wants to copy previous example 2, example 3 are able to see. If you want to copy example 1, let me know. I'll show that. First copy this. You can copy the example 1. So like this, whenever forces are acting, you have to identify which is the accelerating forces, or which forces will cause the motion, which forces will cancel out. So you have to identify that. Okay. So this first complete this, I'll keep the example 1. How was the complete data? Okay, finish that. Force is activation. Counter M is equal to activation. The first is the fundamental law. Okay, hello Srjc. Anyone ready? Okay, Vashika, very good. Next, let us go with the example 4. Okay, for the example. Change it, no? Okay. So for example 4, I'm keeping some what's that heading? Motion of objects on smooth inclined plane. As I told you, okay. So here all surfaces will be smooth. In Newton's laws of motion, all surfaces will be smooth. Okay. So now I'm taking the smooth inclined plane, something like this, of inclination theta. On smooth inclined plane of inclination theta. Now I'm keeping an object of mass m, block of mass m. Not on the block, we keep any object of mass m. Okay, block of mass m. Then what happens? Will it stay there or slide down or go up? Slide down, go up, and stay there. Which option you will choose? It's very smooth. Yes, it will slide down. Then find the acceleration of the block. With what acceleration it will slide down? With what acceleration it will slide down? I don't know what is the FL I'm asking. I'm asking what is the acceleration of the block. Find the acceleration of the block with which it will come down. I'm asking what is FL? F by mg now. Why it is F by mg? F by mg is there. This should not be there. Okay. See, we know that it will slide down. Am I right? It will slide down. What is F bottom? As it is sliding down, let us say this is sliding down. It will slide down. Now we have to identify the force which is acting down the inclined plane. Am I right? So there should be some force, no, to slide down. To move the body, force should be there. So what are the force acting on the block? Now identify the force acting on the block. Mg will act. Am I right? One force. The other force is normal reaction by the inclined plane. Normal reaction by the inclined plane will be perpendicular to contact and away from it. So these are the two forces acting on the block. Even in free body diagram also we have drawn this diagram. In free body diagram I have given so many things related to questions. Questions related to the free body diagram already draw this. Very good, Nikhil. So then see, this is the mg, and if I extend it, if I extend this, now mg is not in the direction of the motion. Even normal direction also not in the direction of motion. Direction of motion mg activated, the normal direction will activated. Then we have to identify the components which are acting in the direction of motion and which components will cancel out. See, perpendicular to inclined plane, object cannot move. Perpendicular to inclined plane, object cannot move. Object cannot move along the normal action direction, right? It cannot move up, no, it cannot move down, which is perpendicular to inclined plane. But it can slide along the inclined plane. So that's why what we are doing, this is theta, this has to be how much? What is this angle? Already kind of we discussed. What is the angle? This angle is 90, this angle will be 90 minus theta. So this angle will be theta. Total should be 90. Already I told that, these components. Components is, so this is theta, no? This is 90. Then what is this angle? Now imagine this is the triangle. Imagine this triangle. If you see this triangle, total angle should be 180. One is 90, other one is theta, then other one will be 90 minus theta. So total angle should be 90, so other angle will become theta. All of understood the angle theta, na? We need out in this. Then I can make into components. Mg I can make into components. This is mg cos theta, and what the other component is? Mg sin theta. Cos component is there along the line with which it makes an angle theta. Okay, the mg is making angle theta with the perpendicular. So if theta is the inclined plane angle, you can remember in this way. If theta is the inclined plane angle, inclination, then mg sin theta will act down the inclined plane on the object. Mg cos theta will act perpendicular to inclined. Mg cos theta will act perpendicular to inclined. Mg sin theta will act down the inclined. Now tell me which forces will cancel out. Which forces will cancel out? The forces which are perpendicular to inclined plane will cancel out. See, along the red color direction, object cannot move. Red color direction, object cannot move. So then, so can I say that object is in equilibrium along this line? Okay, na? Object is in equilibrium along this line. Okay. So then I can write down what? I can write down that normal action theta. Then what is the accelerating force? The accelerating force. Okay, na? Mg sin theta will be the accelerating force. Then what is the acceleration? Block is what is acceleration net force by mass. What is force that is? Mg sin theta by m. Then m and n goes off. What is the acceleration? It's a standard result. Try to remember. What the acceleration of the block is? Mg sin theta by m. which is equal to g sin theta. That means you keep any object on the incline. You keep any object on the incline, that block will come down, or that object will come down with what acceleration? Acceleration g sin theta. G sin theta will be the acceleration of the block as you are keeping on the inclined plane. Which inclined plane? Obviously smooth inclined plane. So this fact is also important. Because after friction, so they will give smooth inclined plane and rough inclined plane. Then you have to verify it properly. Very good, Najla. Okay, wrote down. Anybody ready? All of you understood this? This is important phenomenon. This is important phenomenon, and most of the time should be. All of it see the components also. Just a minute. So, आप okay, good. Gautam, voice is not clear. Just a minute. So let me switch the. Gautam, okay now? Gautam, understood now? Okay. Sorry. All of you wrote down? Anybody ready? So you keep any object, that object will come down with what acceleration? It will come down with an acceleration of g sin theta. Okay. So remember this. Now we see the little magic. Magic means it's a logic. Okay. So in physics, magics are logics. That's it. Okay. All of you wrote down it seems, right? Then I'll give you one thing. You can say one question. One question or one idea. Okay. So let us see that there is one inclined plane. Okay. So this is fixed inclined plane. What is the meaning of fixed inclined plane? Inclined plane is fixed. Inclined plane does not move. And height of the inclined plane is h. H is the height of the inclined plane. Now I'm keeping a block of mass n. I'm keeping the block of mass n. Let's make it. As I'm keeping the block of mass n at the top, then find the time. Find the time taken by the block to reach the bottom. Find the time taken by the block to reach the bottom. Final what will happen? It will slide down, no? It will slide down. As it is sliding down, so it will reach the bottom after some time. So now we want to identify what is that time value. So then you will find one interesting result. Now I want time value. So it's something related to previous part. See, these two have some relations. Obviously, right? So as you are keeping the object on the inclined plane, it will come down with what acceleration? G sin theta. It will come down with acceleration G sin theta. So with that logic, you have to make to reach the bottom. Then how much time it will take to reach the bottom? So like this, one will be related to other. Now you can see how physics is, actually how physics will go. Basically, I'm asking time, not velocity, not asking measurable second. So you will get some value. Okay. See, I'm solving it. Now, as I'm releasing this body, so time taking a block to reach the bottom. If you want, you can add one more statement to the question. Okay. Reach the bottom. If it is released at the top. What is the meaning of release at the top? Means initial velocity of the block is 0. Then with what acceleration it will come down? We know the acceleration now. What is the acceleration value? G sin theta. G sin theta is acceleration. Very good, Glory. Sin theta is there. I think sin theta has to cancel out. Sin theta will cancel out, no, Glory? No, it's not cancelling out. Huh? Okay. Let us see. I think it does not cancel out. It has to cancel. Let us see. Okay. So then how much length it will travel to come down? We don't know that. That length I'm taking as L. L is the what? Length of the inclined plane. L is the length of the inclined plane. So to reach the bottom, how much distance it has to travel? L length it has to travel. Let us say, suppose L is the, let us say L is the length of inclined plane. Length of inclined plane. H is the height. And G sin theta is the acceleration. What is the initial velocity? 0. So then can we use kinematic equations? Here acceleration is what? Constant. G sin theta is constant. No, acceleration is constant. Initial velocity, I know. U value is 0. I know what is the displacement. L is the displacement. Okay, with what acceleration? G sin theta acceleration. So then I want to find out the time value. Then I can find out the time value by using kinematic equation. So see, actually we are doing the Newton laws of motion, but we are still going to use the kinematics. Okay. So then I can use S is equal to ut plus half at square. Okay, so what is the displacement it will travel? L. What the u value is 0 plus half into a value g sin theta into t square. Now what is L value? L value is not given. In the question they have given height value. Height is given, no, L is not given. Then how to convert the L and height? L in terms of height. L is hypotenuse, H is opposite side. H is opposite side, L is hypotenuse. Then I can write down sin theta is equal to what? H by L. L is equal to H by sin theta. Okay, na? So this is H by sin theta is equal to half into G sin theta into T square. This side does not cancel purely. Then what is T square I can write down? T square I can write down as 2H by G sin square theta. Okay, 2H by G sin square theta. Then what is the time taken to reach the bottom? The time taken to reach the bottom is 1 by sin theta under root 2H by G. 1 by sin theta under root 2H by G. Because one under root sin square theta will be there, no? Under root sin square theta, 1 by sin square theta will be there. That will come as 1 by sin theta and root 2H by G. So this is the time taken. This is the time taken to reach the bottom of inclined plane. Okay. Or if you copy this, if you have any doubt, let me know. So root of 2H by G sin square theta. Root of 2H by G sin square theta. Sin square theta is there under root. Then it will come out as sin theta. So as the theta value changes, time taken to reach the bottom also changes. Okay, na? As the theta increases, it will take less time. Okay, first write down this, I tell you that. I'll tell you that comparison. Okay. Okay, let me know if you completed it. Okay, finish that. Okay, Rhoda. Then you can compare with different angles. Now time value depends on what? Not only height of the inclined plane, it also depends on the theta angle. Okay. Now, let me draw three different cases. I think all of you wrote down. Anybody writing? If anyone writes, let me know. I'm ready, huh? Okay. So now I'm going to take three different inclined planes. Let us say this is the one inclined plane. Okay, na? This is the second inclined plane. Okay, just let me draw them one more diagram. See, all will have the same height. Huh? So slowly slope is increasing. See once. All are having the same height. H is the height. Okay, all are having the H is the height, but angles are different. This is theta 1, theta 2, and theta 3. Tell me what is the relation between theta 1, theta 2, theta 3? Relation between theta 1, theta 2, theta 3. Which one is least angle? 1, 2, 3. You can answer in terms of 1, 2, 3. Which one is the least angle? Very good, Ramesh. Which one is the least angle? Very small angle. Theta 1 will be least. Okay, yes, correct. Theta 1 will be least. Huh? Okay. So theta 1 is less than theta 2, less than theta 3. So as you're going right, the slope value is increasing. Okay. Now, if I'm keeping an object of mass m, all are released at the same instant. If all the blocks are released at the same instant, which block will win? Let us say A, B, C. If all are released at the same instant, if all are, see, this is common sense question. This not require any physics. Physics అవసరం లేదు. కావాలంటే ఇదే diagram చూపించండి ఎవరికైనా. ఇంట్లో చూపించండి. So you ask them which block will come first. So they'll say without any thinking, without any calculation, they'll say that C is the block because slope is more. Slope is slant, no slant. If slantness is more, then automatically it will come down faster. Okay, so then theta C will be time C. I mean time taken by C will be least comparatively B, comparatively A, because the time value is inversely proportional to sine theta. As the theta value more, sine theta value is more, then time value will be less. Okay, Anilda. Finished. Okay. Understood this logic? All of understood? Okay, very good. What you wrote down? Anybody writing? So like this, we need to identify the acceleration of the bodies, velocities of the bodies. They can ask you velocity, they can ask you time taken. Because all are, see, once you know the acceleration, you can find out all the quantities like velocity, displacement, time taken to travel some displacement. So all the things you can find out now. Okay. So entire kinematics will be there after this. Okay, once you find out the acceleration, entire kinematics is there. Okay, you can relate the kinematics also. Okay, finished now. So till now we have seen that only one block motion. See, one block is moving. In all cases, I have taken only one block. One block is moving. Now let us go with the blocks in contact. Okay. Next is what? Motion of blocks in contact. Now blocks will be in contact. Then we have to identify the motion of the blocks. So how? Let us say this is the ground again, smooth surface. Now I'm taking that there is a block of mass M1 is in contact with the M2. There are two blocks, M1, M2. M1, M2 blocks are in contact. This is the contact. Now we are applying the F force. Then what happens? If I'm applying the force F towards right, then what happens? All of you imagine and tell me. I think Nazia, Vera Positioning, and who else? Glory, somebody is there. Forgot. Vakshini is there. Okay, so all you have to solve this because these things we discussed already. M1 and M2 are the two blocks. If I'm applying a force, then what happens? Both the blocks will accelerate. Both the blocks will move forward. M1 will move forward, even M2 also will move forward. Both will move. Very good, Gautam. Can you say that both will move with the same acceleration because they both will move together? M1, M2 will move together. Together. M1, M2 separately move out. They don't move separately. They will move together. So I can say that the acceleration of M1 will be equal to acceleration of M2. Acceleration of M1 and M2 will be same. Both will travel with the same acceleration. Now the question is, what is the acceleration value? What is the acceleration of the blocks? As we apply the force, they will accelerate. So what is the acceleration of the blocks? Very good, Chandra. This is very what is a fundamental example. Fundamental example for blocks are moving together. Okay. Let us see how to do this. So can you say that both the blocks will accelerate forward with acceleration in? Acceleration of M1 and M2 will be same because both will move together. M2 move అవుతుంది, M1 కూడా move అవుతుంది. So already I told that as we are pushing the M1, M1 will try to push the M2 with force F, which I called as contact force. I think all of you remember. Already discussed in free body diagram. Then M2 also will apply the contact force on M1. F is the contact force. Equal and opposite and perpendicular to contact, which is nothing but normal force. We are calling it as a contact force. Okay. So both are moving horizontally in forward direction. Now I'm drawing the free body diagram of M1. What is the free body diagram of M1? On M1, what are the force acting? On M1 forces are M1G will act downward and the normal dash will act upward, and vertically blocks are not moving. See, as we are pushing them, the blocks are moving forward. As you are pushing them, blocks are moving in forward direction. Means along the horizontal they are moving. They are not moving along the vertical. Along the vertical they are not moving. So along the vertical forces will cancel out. So you can write down N1 should be equal to what? N1 is equal to mg. But it will accelerate forward. It will accelerate forward because of what forces? F and F. See, there are two forces acting on M1. F is the force we applied. Small f is the force which is acting on the M1 by M2. Okay, this is called as free body diagram. So as the M1 is accelerating forward, which force should be more? See, there are two opposite forces are acting, no? Capital F and small f. All of you see the M1 diagram? If you see the M1 diagram, capital F and small f are the forces which are acting opposite to each other. Then, but block is moving towards right. That means F is more than F1. Capital F is more than small f. If capital F is more than small f, then only block will move towards right. Something like in example 2. Notebook example 2 show me. You see example 2 in the notebook. 30, 10 I have given or something like that. Yes. So these two forces are opposite each other. Then what the acceleration I can write down? Acceleration is equal to net force by mass. Or net force is equal to what we can write down? Mass into acceleration. Because block mass is constant here. Net force value F minus F is equal to M1 into A. Mass of the block is M1, acceleration is 0. So this is the equation for the first block. Unbalanced force equation. You can call it as what? Unbalanced force equation. Similarly, we have to write down for M2 also. We have to write down for M2 block also. So free body diagram of M2. So on M2 block, M2G will act downward. Normal reaction on M2 block is acting upward. Again, vertically, cancel out, vertically block is not moving. Then N2 should be equal to M2G. This is M1G. Here only one force will act towards right. F is the force acting towards right. Only one force will act. No other force is there, right? So what I can write down? I can write down that because of this force only, the block M2 block will accelerate. So M2 is moving because of what? M2 is moving because of the force applied by the M1. But M1 is moving because of the force applied by S. Total system is moving because of the force applied by S, which is capital F. Capital F is the force which is applied by S. Okay, no? So then I can write down what is that? Again, same. F net is equal to MA. What is the second equation? What is the small f is equal to? I can write down M2 into A. F is the net force. Only one force is active. F is the net force which is equal to mass into acceleration. So this is the second equation you got. Okay. So I know the first equation. I know the second equation. First and second equations. So from these two, can we find out acceleration? Yes. How? So I can write down F minus F is equal to M1A, F is equal to M2A. If I add these two equations, if I'm adding these two equations, minus F and F will cancel out. We'll get F only, which is equal to M1 plus M2 into A. M1A plus M2A, A in common the M. Then M1 plus M2 into A. That implies what is the acceleration value? F by M1 plus M2. What is the acceleration value we can write down? F by M1 plus M2. Okay, if I know the acceleration, I can find out the F value. F value also you can find out, which is small f. So what is the force acting? Contact force acting on M2 by M1 or contact force acting on M1 by M2? Anything is same. So what is the contact force between two objects? F value. Small f value also you have to find out. Find the contact force between small f and small f value between M1 and M2. Good notes I think I tried. Good notes I tried, but this is notability. Notability has some good features. So you can keep all notes in a proper order. Good notes, it will be something like in 5 stories. So we cannot make the divisors. So something like this. So I can keep all the notes as a divisors. Divisors. But we cannot do this one in good notes. I don't know whether there is any update or not. Let me see that. Okay, go down now. Find the smaller value. So what is the contact force between M and M? Okay, go down now. Anybody writing? Okay, completed that. Very good. And how to find that smallest value? If I know the acceleration of the blocks, okay, so I can go for F is equal to second equation. F is equal to M to A, then M2 into F by M1 plus M2 will be the contact force between M1 and M2. The force acting on M1 by M2 or force acting on M2 by M1. Anything. Okay, no? So here, if you see this formula, acceleration is equal to F by M1 plus M2, then we can write down one thing. Acceleration is obviously net force by, you can write down total mass. What the total mass of the system is M1 plus M2. Total mass is M1 plus M2 and force is F. F is the force, net force. Now you take the M1 plus M2 as a one block because they are moving together. No? As they are moving together, you can take like a one single block. If objects are moving together, you can take like them as a single block. Okay. Then acceleration is equal to net force by total mass. Then you get acceleration. But you require the free body diagram to calculate the contact force. For contact force, you require the free body diagram of block. Okay, so I'll explain this in detail also. Don't worry, you will understand it. You will feel it. So just write down acceleration net force by total mass of the system. Okay, go down. Anybody ready? Tanuja? Okay. So now let us go with the next case. But you can say this is the first case. Let us go to the second case with three blocks. This we are extending our idea. M1, M2, M3, and this is the force. Okay. So what we have to do? We have to find out the acceleration of the blocks. We have to find out Fn, which is force between M1 and M2. Next, find what force between M2 and M3, F2 value also. The contact force between M2 and M3. So now solve for three blocks. Solve for 3 blocks. Okay. Okay. And yes, Shalila, very good. So as we discussed earlier, acceleration is net force by total mass. Directly you can find out acceleration. If the blocks are moving with acceleration A, so all will move together. As all blocks are moving together, you can take them as a single block. Then what is the acceleration value? You can write down net force F by total mass m1 plus m2 plus m3. This is the acceleration of blocks. Acceleration of blocks. Okay. But not all acceleration. No, we require what? We require the forces. Let us say M1 will apply the force on M2 F1, then M2 will apply the force on M1 F1, action reaction. So similarly, suppose M2 is applying the force F2, then M3 will apply the force on F2. So action reaction phase. Contact forces F1, F2. Then what is the free body diagram? Free body diagram of M1. Free body diagram of M1, if I draw, then on M1, F is the force acting, F1 is the force acting, M1G is the force acting, N1 is the force acting, and M1G and normal action cancel out. Vertical forces will cancel out. So then it will accelerate with acceleration A. Then what is the equation we can write down? Net force is equal to mass into acceleration. What is the net force is? Net force is equal to M into A. What is the net force value I can write down? F minus F1 is equal to I can write down M1 into A. Similarly, what is the free body diagram of M2? What is the M2 free body diagram? On M2, F1 is the force acting forward. Because of this F1 only it will accelerate. And F2 also will act because of M3 block. Then M2G will act downward. Normal reaction will act upward. So again, vertical will cancel out. N2 value is equal to M2G if you want to write. N2 is equal to M2G. N1 is equal to M1G. Okay, so then still it is accelerating with acceleration A. Then I can write down F1 minus F2 is equal to M2 into A. Directly I'm writing equation now. See, F1 minus F2 will be the net force because both are opposite each other. F1 and F2 are opposite each other. So then F1 minus F2 is equal to mass into acceleration, M2 into A. So this is the first equation, second equation, and third equation. Free body diagram of M3. So if I want to draw the M3 free body diagram, that would be something like this. Then M3G will act downward. Normal reaction M3 will act upward. So again, M3 value is equal to M3G, both will cancel out. And why M3 will accelerate? Because of F2 force. Because of contact force between M2 and M3 F2, so M3 is accelerating. Then F2 is equal, because only one force which is accelerating, that I can write down as M3 into A, because it will accelerate with the acceleration A. So this is the third equation. So if we can solve for 3 equations, then we can solve the question. We can solve the A value, we can solve the F1 value, we can solve the F2 value. 3 unknowns and 3 equations. మీకు మ్యాథమెటిక్స్ ఎప్పుడు కూడా ఎన్ని అన్నోన్స్ ఉంటే అన్ని ఈక్వేషన్స్ ఉండాలి సాల్వ్ చేయడానికి. ఓకే, సో దెన్ f minus f1 is equal to m1a, f1 minus f2 is equal to m2a, f2 is equal to m3a. If I add them, f1 f1 cancel out, f2 f2 cancel out. Okay, so అందుకే ఒక సిస్టమ్ ని తీసుకున్నాం అనుకోండి, m1 m2 m3 we take it as a single body, then f is the force acting. That's what I wrote here. I wrote by taking the all three bodies as a single body. But for acceleration it is okay. But if you want to find out f1, then you cannot do with a single body, or take separate bodies. So then if I'm adding, then f is equal to, I can write down m1 plus m2 plus m3 into a. Then what the acceleration I'll get? Acceleration I'll get f by m1 plus m2 plus m3. Then we can find out f2 value. f2 is equal to m3 into a. Then m3 into f by m1 plus m2 plus m3. This is f2 value. Once you know the f2 value, you can find out f1 value. Okay. So f1 minus f2 is equal to m2a. Then f1 is equal to f2 plus m2a. What the f2 value is equal to? f2 value I can write down m3a. Then what the f1 value finally? m3 plus m2 into a is nothing but m3 plus m2 into f by m1 plus m2 plus m3. This is the f1 value, which is the force between m1 and m2 blocks. Okay, I think by this time you understood vertical forces will cancel out. Weight and normal action cancel out, so no need to consider them in this particular conditions cases. Okay, vertical forces will cancel out. You have to worry about only horizontal forces. Okay, go down. Are everybody ready? Okay, and is it completed? Next. Okay, similarly, we can solve for objects, motion of objects which are connected by strings. That also we can do. Okay, so that part we see tomorrow. So how the blocks will move when they are connected by strings. Okay. Let's stay completed. Okay. So if anyone writing, I'll wait. Please let me know. Gautam finished up. Nikhil, Gautam, Conrado, Adil. Okay. Okay. Completed. Everybody. Solution completed. Okay. So by one, all of you revise these things. Okay. No? So tomorrow we meet and we discuss the motion of the objects connected by strings. See, please revise all these things. Otherwise, you'll find little tough to follow the class. Revision is compulsory. Revision of the class is compulsory. Okay. Yeah. Bye everyone. We'll meet tomorrow.